reading resistors, resistor color code. When you look at majority of the linear resistors we have, you would observe that the colors are grouped into two. The group 1 contains 3 or 4 colors, while the group 2 contains 1 or 2 colors. These colors are separated by a gap. Now, to read a resistor, you must turn the resistor in such a way that the group 1, which contains 3 or 4 colors, are on your left hand side, while the group 2 of 1 or 2 colors are on the right hand side. The colors on the resistors are actually used to determine the value of the resistor. And resistors that have 4 colors on them, we use the 4-band color code system, while resistors that have 5 colors on them, we use a 5-band color code system. And the 6-band color codes are for resistors that have 6 colors on them. The first group 1 that has 3 or 4 colors contains the digit and a multiplier. The digits might be 2 or 3, while the multiplier is just one of them. Now the group 2 colors have 1 or 2 colors in them, one of which is a tolerance and the second is a temperature coefficient. So here's a table of value that helps us determine the value of a resistor simply by its color. 4-band color code. Here's a typical resistor. The first is a digit, second is a digit, the third is a multiplier, and the fourth is a tolerance. Let's go over it again. This time around, we say together. The first is a digit, second is a digit, the third is a multiplier. So what do we do with it? We write the first digit, the second digit, multiplied by the multiplier plus or minus the tolerance. Let's look at this example. The first is a brown, so we have a 1. Second is a black, which is a 0. The third, remember, is the multiplier, so it's 10 to the 0. So what do we write? We say the digit times the multiplier. We have a 1, 0, which is the digit multiplied or times. So we have the 10 times 10 to the power 0, which means the first digit, the second digit times the multiplier, which is 10 to 0. The fourth is the tolerance, which is plus or minus 2%. So we will say 10 plus or minus 2%. 10 times 2 divided by 100 equals 0.2 ohms. The range of this resistor will vary between 10 plus 0.2 or 10 minus 0.2, which is 10.2 or 9.8 ohms. Easy, right? Let's look at another one. The first color is a red, so we're having a 2. Second is a gray, so we're having 8. The third, remember, is a multiplier, so we're having a 10 to the power of 1. So what do we write down? We have a 28 times 10 to the power of 1. The fourth value is a gold, so that's a plus or minus 5%. 28 times 10 to the power of 1 is 280. So 280 ohms plus or minus 5%. We say 280 multiplied by 5% give us 14 ohms. So it means that the resistor could vary between 280 plus 14, that is 294 ohms, or 280 minus 14 gives us 266 ohms. Now we'll try this together. The first is a what? Good. The second color is a good. So what would the third be? Would it be a digit or a multiplier? A multiplier. So that's 10 to the third. So what do we write down? 22 times 10 to the third. The fourth digit is the tolerance plus or minus 1%. So we're going to be writing 22,000 plus or minus 1%. So 1% of that 22,000 gives us 220 ohms. So it means that the resistor value could actually vary between 22,220 ohms or 21,780 ohms. We could simply change this value to kilo ohms by making it 22.2 kilo ohms or 21.8 kilo ohms. Here's another example. The first is 2, second is what? A 1. The third is the multiplier, which is 10 to the 4th. So what do we write down? We have 1 times 10 to the 4th. The fourth color is also a gold, so plus or minus 5%. So we're having 210,000 ohms plus or minus 5%. So 5% of that value, we would say, would give us 10,500. That is approximately 223 kilo ohms or 200 kilo ohms. Let's try this now. The first color, the second color, the third, is it a digit? No, good, a multiplier. So what do we write down? So it means that this resistor will vary by 83 ohms. So 363 ohms or 327 ohms. Please feel free to leave the answer in the comment section below. 5-band color code. The first is a digit, second is a digit, and third is a digit. The fourth now becomes the multiplier. The fifth is the tolerance. We're going to take it together. The first is, second is, the third. So how do we write this down? We say the digits times the multiplier plus or minus the tolerance. Let's solve one. The first is a red. The second is a red. The third is a digit, which is a black. The fourth is a multiplier. So we're having 220 times 10 to the power of 2. And the fifth color is silver, which is plus or minus 10%. So representing this, we'll say 22,000 plus or minus 10%. So 10% of that would give us 2,200. So this resistor would vary between 24.2 kilo ohms to 19.8 kilo ohms. Let's try another. The first is an orange, that is 3. Second is a violet, which is 7. Third is a black, which is 0. Fourth, which is the multiplier, then times b, 370 times 10 to the power of 1. The fifth color is a gold, that is plus or minus 5%. 3,700 plus or minus 5%. 5% of the value will give us 185 ohms. So this resistor would vary between 3,885 ohms to 3,515 ohms. So let's do this together. The first color is a brown, which is, the next color is a black, which is, the third color is, good. Now the fourth color is an orange, that's 10 to the third, and we have 100 times 10 to the third at plus or minus 5%. So what we write down, we simply write 100,000 plus or minus 5%. So this resistor would vary between 105 kilo ohms to approximately 95 kilo ohms. Please solve the following. Please feel free to leave the answer in the comment section below. 6-band color code. Here's a resistor with 6 colors in it. The first is the first digit, second is the second digit, third is the third digit, fourth is the multiplier, the fifth, remember, is the tolerance, and the sixth, the temperature coefficient. We'll take it again. So that's the first digit, next second digit, next third digit, next the multiplier, The fifth, the tolerance. So we'll say first, second, third digit times multiplier plus or minus tolerance at the temperature coefficient of resistance. I will express that in ppm per degree Celsius or in Kelvin. ppm simply means part per million for every temperature change. That is, at y ppm per degree Celsius implies that resistor changes by y at every temperature change. So to calculate this, we say the resistor value times y divided by 1 million equals Z ohms. So for every change in temperature, the resistance of this resistor changes its value by Z ohms. That is, first, second, third digit times the multiplier plus or minus the tolerance at whatever value it is, ppm per degree Celsius. The first is a green, second is a blue, third is a black, the fourth is it a multiplier or a tolerance? Good, tolerance. Then plus or minus 10%. Since that is silver, so 10% of that value will give us 56 mega ohms, between 616 mega ohms to 504 mega ohms. Now the sixth is the temperature coefficient, which is valid, and that on the table is 5 ppm. So at 5 ppm per degree Celsius change, the resistor changes by 2800 ohms. So let's try this together. The first is a red, which is 2, second is a green, which is 5, third is a black, which is 0. So the fourth color, what is that? The multiplier. Good. So we have 250 times 10 to the 7th plus or minus 5%. So that gives us 125 mega ohms. So the resistor value would vary between 2625 mega ohms to 2375 mega ohms. Now the sixth color is the temperature coefficient, which is brown, and that is 100 ppm. So at 100 ppm per degree Celsius change, it means that this resistor would vary by 12,500 ohms. So to express this properly, we would say 2,500 mega ohms plus or minus 5% at 100 ppm per degree Celsius TCL. So let's try this on our own. Feel free to leave the answer in the comment section below. Surface mount technology, or the SMDs. The surface mount device code for resistors have two. The first is a 3 and 4 digit system and the EIA96 system. Now for the 3-digit system, the first two codes represent the significant value, while the third code represents the multiplier. So let's do that together. We have 35 being the significant value times 10 to the power of 0, which gives us 35 ohms. For the 4-digit system, the first three codes represent the significant value, while the fourth code represents the multiplier. Let's try it again. 633 represents the significant value, and 4 is the power. Let's try another. 128 represents the significant value, and 0 is the power. Now if a letter R is found on the resistor, the position of the R represents the decimal. .7. In the case where we have the digits on the line, then the value begins with a decimal. So pause the video while you try and answer this on your own. The EIA96 system. On the EIA96 system, we have at least 2-digit code which will be used to get the resistor value from the manufacturer's datasheet, and a letter which will be used to get a multiplier on that same datasheet. We have 14, and 14 is 137, and the letter Z from our table is 0.001. So we have 0.137 ohms. Let's try another. 27 from your table is 187, and the letter D from our table is 1000. So we're having 187 kilo ohms, or 0.187 mega ohms. From your table, what is 12? Good. And what is the letter R? 0.1. Good. So we have 1.30 ohms. Pause the video and do this on your own. Please feel free to leave the answer in the comment section below. And also, try this.